Imagine crossing continents in the blink of an eye. Yes, we're talking about teleportation. Picture this. One moment you're sipping coffee in your living room, the next you're standing on the summit of Mount Everest, the icy wind whipping around you. Sounds like magic or something straight out of a sci-fi movie, right? Teleportation, the idea of moving instantaneously from one location to another without physically traveling the distance, has been a staple of science fiction and fantasy literature for decades. From Star Trek's transporter beams to Harry Potter's flu network, it's a concept that has lit up our imaginations, offering a tantalizing escape from the constraints of time and space. But why does the idea of teleportation fascinate us so much? Is it the prospect of skipping the morning commute, the allure of instantaneous travel to exotic locations, or just the sheer thrill of defying the laws of nature? Whatever the reason, teleportation taps into our deepest desires for freedom and exploration. But here's the catch. As much as we would love to believe in the possibility of teleportation, it's been dismissed by the scientific community as a mere fantasy. But is it really? With the advent of quantum physics and the exploration of the subatomic world, the lines between science fiction and reality have started to blur. So what if teleportation isn't just a figment of our imagination but a potential reality? What if, one day, we could truly break the boundaries of space and time? And more importantly, what would be the implications of such a groundbreaking discovery? These are the questions we'll be exploring in this video. We'll delve into the science behind teleportation, the challenges it presents, and the potential it holds. We'll also touch on the ethical implications of such a discovery, because with great power comes great responsibility. By the end of this video, you'll know the science behind teleportation, and whether it's a distant dream or an achievable reality. So what exactly is teleportation? Great question. At its most basic, teleportation is the idea of moving something from point A to point B instantaneously. It's like snapping your fingers and your cup of coffee that was on the kitchen counter is now comfortably in your hand. But how is this possible? Well, in theory, teleportation involves the transfer of matter or energy from one location to another without actually having to traverse the physical space in between. Simply put, it's like faxing an object instead of a document. You're not sending the actual object through a wire, but rather, you're sending the information about that object, which is then used to recreate it at the other end. Let's imagine for a second that you've got a teleportation device. You step into it in New York, it scans every single atom in your body, capturing the precise state of each one. This information is then transmitted to Paris, where a second device uses this data to reassemble every atom in exactly the same state. Voila, you've just teleported from New York to Paris in the blink of an eye. But it's not just about people or objects disappearing and reappearing elsewhere. It's about the information. Teleportation is really about transmitting the exact state of something from one place to another. And it's not just science fiction. Teleportation has roots in quantum physics where particles can be entangled in such a way that the state of one can instantaneously affect the state of the other, no matter the distance. Now, we're not saying you'll be able to teleport your car or yourself anytime soon. There are still enormous scientific and technical challenges to overcome, but the concept of teleportation gives us a glimpse into a future where the boundaries of space and time might not be as rigid as we think. In essence, teleportation is the ultimate shortcut. Does science back up teleportation? Let's dive into quantum physics. The world of quantum physics is both mysterious and exciting. It's a realm where particles can be in two places at once, where they can talk to each other instantly over vast distances, and where, yes, teleportation is already a reality. This teleportation, however, is not like in sci-fi movies. It's a little more subtle, but no less mind-blowing. Our story begins with a phenomenon known as quantum entanglement. This is where two or more particles become intimately connected, no matter how far apart they are. Change the state of one particle, and the other changes instantly. This spooky action at a distance, as Einstein famously called it, is the closest thing to teleportation that exists in science. Here's how it works. Imagine you have two entangled particles. Let's call them Alice and Bob. Alice is in New York, and Bob is in London. Now, if we measure Alice and find her spinning clockwise, we instantly know that Bob is spinning counterclockwise, even though he's thousands of miles away. This isn't because of some faster-than-light signal between them, but because their states were always correlated. It's as if the information about their states has been teleported. Now you might be thinking, that's all very well for particles, but what about teleporting something bigger, like a human? Well, the laws of quantum mechanics don't forbid it. But there's a catch. To teleport a human, you'd need to know the exact state of each and every one of the roughly 7 octillion atoms in the human body. That's a 7 followed by 27 zeros, and then you'd need to recreate that exact state somewhere else. It's a task so astronomically complex, it's currently beyond our reach. But who knows? If there's one thing we've learned from the history of science, it's to never say never. So, in the quantum world, teleportation is already a reality, but what about on a larger scale? Teleporting a human is a whole different ballgame. Here are some reasons why. First up, we have the Heisenberg principle. This principle states that it's impossible to simultaneously know the exact position and momentum of a particle. This means that to teleport, we would have to know both variables exactly. Now, this is a bit like trying to catch a bar of soap in the bath. It's slippery and elusive. So, the Heisenberg uncertainty principle presents a significant challenge to the concept of teleportation. Next, let's consider energy. Imagine the amount of energy it would take to disassemble a human being, atom by atom, then transmit that information across space and finally reassemble them at the other end. To give you an idea, to teleport a single human being, you would need an energy consumption rate equal to the entire United States in a year. That's a lot of power. Lastly, there's the complexity of reconstructing a human being. We're not talking about a stack of Legos here. Humans are made up of about 7 octillion atoms, each arranged in a specific way. Not to mention, we're not just physical bodies, we're also the culmination of our experiences and memories. How would one ensure that these are also accurately transmitted and reconstructed? And let's not even get started on the question of whether the teleported person would be the same individual or just a perfect copy. That's a philosophical can of worms best left for another day. Clearly, teleporting a human is fraught with challenges. However, that hasn't stopped scientists from exploring possibilities. Despite the challenges, there have been some groundbreaking experiments in teleportation. Let's take a moment to appreciate the incredible strides scientists have made in this field. Firstly, let's travel back to 1993. A team of scientists at IBM successfully teleported a single photon. This may sound insignificant, but it was the first time an object had been teleported in any form. This experiment was a stepping stone to what we can achieve today. Fast forward to 2014, when scientists at the Kavli Institute of Nanoscience in the Netherlands achieved a remarkable feat. They teleported information stored in a quantum bit or qubit to another qubit about 10 feet away. This was monumental in the field of quantum computing and teleportation, showing that teleportation could be used in practical applications. In 2016, Chinese scientists pushed the boundaries further. They teleported a photon from the ground to a satellite orbiting 500 kilometers above the Earth. This marked the longest distance over which quantum teleportation had been achieved. And just last year, a team from the University of Science and Technology of China managed to teleport 3 degrees of freedom of single photons. This was a significant step forward in the quest for high-dimensional teleportation, which is key to quantum computing, quantum communication, and even quantum internet. These experiments are proof that teleportation, at least on a small scale, is possible. Each of these achievements is a piece of the larger teleportation puzzle. They're helping us understand this complex phenomenon and inching us closer to the day when larger-scale, perhaps even human teleportation could become a reality. But it's important to remember that while these experiments are groundbreaking, we're still in the early stages of understanding and perfecting teleportation. There's a long and exciting journey ahead in this field. These experiments show that while teleporting a human is still far off, smaller-scale teleportation is happening. Teleportation isn't just a scientific challenge, it presents some serious ethical questions as well. As we delve into this intriguing concept, we must ask, is the person who emerges from teleportation the same individual who entered, or are they merely an identical copy? This question is not just philosophical, but may have critical implications for our understanding of identity and selfhood. Imagine a teleportation process that involves scanning your body, destroying the original, and recreating you elsewhere. The you that steps out of the teleporter would have all your memories, personality traits, and physical characteristics. To anyone else, they would be indistinguishable from the original. But from your perspective, would you have simply ceased to exist in one location and started existing in another? Or would you have been destroyed, only for a copy to take your place? Now let's consider the potential for misuse. Teleportation, like any technology, could be exploited in dangerous ways. Consider the possibility of unauthorized teleportations. What if someone could teleport you against your will, or teleport themselves into secure locations? What about the potential for creating multiple copies of the same person? This could lead to unimaginable chaos and a complete redefinition of personal identity and human rights. Moreover, the economic and social implications could be vast. If commuting becomes instantaneous, how would that reshape our cities, our jobs, our lives? Would the rich have exclusive access to this technology, widening the gap between the haves and the have-nots? These are just a few of the ethical challenges that teleportation presents. It's crucial that we address these issues head-on, engaging in thoughtful dialogue and crafting careful regulations. We must ensure that any development in teleportation technology is guided by a comprehensive ethical framework. As with any powerful technology, teleportation comes with potential benefits and risks. As we stand on the precipice of this new frontier, we must navigate it with caution, wisdom, and a deep respect for the profound implications it holds for our society and our sense of self. So, will we be teleporting to work anytime soon? A question that may sound whimsical, yet holds the essence of our exploration today. As we draw conclusions from our voyage into the world of teleportation, let's take a moment to reflect on what we've learned. Teleportation, as we've discussed, is not just a concept confined to the realms of sci-fi novels or blockbuster movies. It's a genuine scientific phenomenon, one that's deeply rooted in the principles of quantum physics. Quantum teleportation, the mysterious process where information is transported from one place to another without traversing the physical space in between, has been observed and verified in laboratories across the globe. However, we've also acknowledged the monumental challenges that stand in the way of scaling this phenomenon up from the quantum world to our macroscopic reality. The sheer complexity of human physiology, and the astronomical amount of data involved in teleporting a human being, are hurdles that seem insurmountable with our current scientific understanding and technological capabilities. Yet, we've also discussed the astonishing scientific breakthroughs that have been made in recent years. From teleporting information over unprecedented distances to the development of advanced quantum computers, these milestones have pushed the boundaries of what we once thought possible. But even as we marvel at these advancements, we've also pondered upon the profound ethical implications of teleportation. Would teleportation devalue the uniqueness of human identity? Could it be used maliciously? These are questions that we must grapple with as we continue to unlock the secrets of teleportation. While teleportation remains largely in the realm of science fiction, the advancements in quantum physics are taking us closer to understanding how it might one day become a reality. It may not be tomorrow, or the next decade, or even in our lifetime, but one day, the dream of teleportation may just materialize into a tangible truth. And perhaps then, we may finally break the boundaries of space and time.